All right, so this is a very similar example to the previous one. This is a think, pair, share. So in a classroom, you would have worked with a colleague sitting next to you and worked together on solving this problem, answering these questions based off of the previous example. So, consider pausing the video or trying this on your own, and then coming back to this video to watch the rest of the solution. So it's pretty much the same problem, just some of the numbers and what you're being asked for has been changed just a little bit. All right, so uh, let's go ahead and work through this one. So the distribution of the weight of male black bears in California is unknown, but measurements indicate a mean of 400 pounds and a standard deviation of 40 pounds. From each sample site in the state, samples of size 18 are drawn randomly from the population. Question 1, what is the probability the sample mean from a sampling site is between 375 and 425 pounds? So we're going to answer this question, by answering all the intermediate parts that are designed to help you kind of understand the concept that I'm teaching here in 7.1. And then question 2, find the value that is 2 standard deviations above the expected value, 400, of the sample mean. All right, I think I've kind of squeezed everything here onto one page. So let's see if we can do that here. So what we're trying to do first is to calculate the probability that the sample mean from a site is between 375 and 425 pounds. So what we're trying to calculate is the probability that the sample mean of any one of these sampling sites will be between 375 pounds and 425 pounds. All right. That's what we're trying to find out. And since we're trying to calculate a probability, remember probability is equal to area under a curve. All right, so we need to find ultimately the area under a curve to calculate this probability. All right, so to find the random variable x literally and in notation form. So the random variable, let me go ahead and use black here. So the random variable x, capital X, is going to be defined as the weights of male black bears in California. And to write this in notation form, remember that notation form would look something like this. And so notation form for this random variable. Um, so, we would put an N if it's normally distributed. We put a U if it's a uniform distribution. But in this particular problem, we're told that the weights of male black bears has a distribution that is unknown. So we don't know what shape that distribution of male black bear weights takes. So I'm just going to put a question mark there. But we do know that it has a mean of 400 and a standard deviation of 40. All right, so these are the two answers for those two parts. Okay, part B is define the sampling distribution of the mean. All right, and the reason why I'm having you do this is to differentiate between these two. All right, so the sampling distribution of the mean, this capital X bar, is going to be defined as containing the means of samples of black bears in California with a sample size of 18. All right. And so what's the difference? Um, capital X is composed of individual weights of black bears. Capital X bar is composed of means from multiple samples. All right. Part C is write the question in the form of the probability of an event. So actually, I kind of gave that away. It's up here. So what's the probability that the sample mean from any one of these sampling sites is going to be between 375 and 425 pounds? All right, now visualize the problem with a picture of a normal distribution. So again, it's always good to put in your givens. So we know that the mean of the population is equal to 400. And what we also know is that the mean of the sampling distribution is also going to be equal to that. We know that the population standard deviation for the weight of bears is 40, but we do not know what the standard deviation is of the sampling distribution of means of bear weights. We don't know what that is. So, you know, these two variables go together, as well as these two variables go together. We know what the value of this one is, but we don't know what the value of the standard deviation is. That's what we got to figure out. And the size of each sample at each sampling site is 18. So the picture that we're going to draw is going to look something like this, where the center of it is 400, and that represents the mean of our sampling distribution, the mean of our sample means. And we want to try and find the area between 375, which is going to be below 400, and 425, which is above it. So between those two is going to be this area. So this area, actually I should draw it off to the side here. This area is going to be equal to that probability. All right. Now to be able to calculate this area and use a CDF function, we're going to need to know what the standard deviation is for this distribution. So how do we figure that out? Well, we figure that out from this algebraic relation. The standard deviation for the sampling distribution of the mean, so the standard deviation of this distribution of this curve, is equal to the standard deviation of our population divided by the square root of our sample size. And so the standard deviation of the population came out to 40, and we're going to divide that by the square root of 18. And we can plug 40 divided by the square root of 18 into the calculator. And let's go ahead and do that. So I'm going to go into the calculation app, and I'm going to put 40 divided by the square root of 18, and I get approximately 9.43. All right. Or 9.428. Okay, so that gets us our standard deviation there. Um, let me see here. So we still have to calculate the area. We haven't done that yet. So we need to use a normal CDF function. And what I'm thinking about doing is, how do I avoid using a rounded value here when I use a CDF function? So let's continue with the numworks calculator first, since I just kind of started that. So I'm going to take this value and I'm going to put this in the letter O, to represent sigma. Okay. So if I want to take this recent value and store it, then I can use this orange arrow that's on this X to the Y key. So in order to use that, I hit Shift and then this arrow, and it's going to take my answer and store it in whatever letter I want. And I think I want to put that, I think I can make it a lowercase o just by hitting alpha and 9. Let's see if that works. Okay, I think it worked. All right, so it took this fully accurate decimal number here and it put it in this variable O in the calculator. Now let's do the same thing with the Texas Instruments calculator. So here I'm going to put 40 divided by the square root of 18 to get that answer. And then I'm going to store it. Okay. Uh, Bottom left-hand corner of the calculator, there's a key STO arrow. So I'm going to store that. Now, I don't think I have the option of upper and lowercase. Oh, I do. No, not really. I say UVW, but I think that means something else. So I'm going to use a capital O. And so it's in green. So I need to hit the green alpha key, and then the 7 key, and that'll put an O there. And I can hit enter. Okay, that stored that value in that letter O. All right, so we need a CDF function in order to, we need a CDF function in order to calculate the area between two numbers. So I'm going to come over here to Texas Instruments first. So it's going to be in the distributions menu. So I need to hit second, then the vars button, come down to normal CDF, hit enter. Okay, the lower number was 375. The upper number is 425. The mean is 400. Now, the standard deviation we want to use is this new standard deviation that we calculated, 9.428. And I store that in letter O. So to get that value back, I want to put letter O in there. So I'm going to hit alpha and then 7. And yeah, that put an O right where I need it there. Now, I'm not going to hit paste just yet because I want to use these numbers here for the numworks. So in order to get the similar functionality, I want to hit the home button, go down to the distributions app, and we're dealing with a normal distribution. We've got a mean of 400, standard deviation. So I put that in lowercase o. So I'm going to hit alpha and 9. That puts an O there. Again, oh, I was going to say, I didn't test this. It looks like it's working just fine. Okay, and I'll hit next. Now what I want is I want the area between two values. So I want this option, this middle option. Click OK. And I want the area between 375 and 425 And you can see here, this is what I put in previously. I put in 400 and then I put that variable in. It's rounding it. It's rounding it to display it, but it's using the fully accurate decimal place equivalent here. Um, yeah, and so now I can hit execute and I get 0.9919. And if I do the same here on the Texas Instruments, 0.9919. Okay, so we can come back to our problem. And you can see I rounded that to 99.2. So the probability we're going to get from 375 to 425 is going to be equal to 0.99. I'll just put 19 and some change, which comes out to 99.2%. Okay, so that's the final answer we were looking for uh, in question one. Now, the next one is find the value 2 standard deviations above the expected value. So for this, I'm going to use the algebraic relationship. Oh, come on. Okay, I'm going to use the algebraic relationship. Just going to be x bar equals sigma x bar z plus mu x bar. And this value we just saved came out to 9.428. And that's going to be times z, which is 2, because we're looking for a value 2 standard deviations above the expected value. And because it's above, we're going to put a plus here. So it's a positive 2. Okay. If this had been 2 standard deviations below the expected value, I would have put a negative. It would have been a negative 2. And this is 400. All right. Just really quick, let me show you maybe how to, use that letter O again in our calculations. So if we go to the NumWorks calculator, let's go back to the home screen. So we can go to the calculation app. And I want to use the lower capital letter O. That's the standard deviation times 2. And then that's going to be plus 400. There we go, 418.85. And then with the Texas Instruments, we can do the same thing. So here we have to use a capital O, so it's going to be alpha 7 times 2 plus 400. And you can see we get the same answer. All right. So this is going to be, what did I say, 418.9? So that's the mean value. That's 2 standard deviations above the expected value of 400. All right, so that concludes that think, pair, share. Let me know if you have any questions.